Today we're going to jump into double angle formulas. Now what I've got initially for you is I've got our example of sum and difference. If we want to take and add two different angles, 30 and 45, we'd use the sum, sine, cosine, cosine, sine. Let's say I want to find the sine of 2x, which is the same as an angle plus itself. Well, I could use a sum and difference and say the sine of the first angle x times, or cosine of the second angle, which is also x, plus the cosine of the first angle x, sine of the second angle x. You'll notice because of commutative property of multiplication, these two terms are actually the same. So what I really have is I have the sine of 2x is equal to 2 sine cosine. And that's the double angle identity, or the double angle formula for the sine of 2x. That you're going to have to probably memorize, or if you know your sum and difference, you can derive it. Next, let's do the same with the cosine of 2x, which is the cosine of x plus x. So we know that's cosine of the first angle, cosine of the second angle, minus sine of the first angle, sine of the second angle. So the identity, or the formula for the cosine of 2x, is cosine squared minus sine squared. But because we have Pythagorean identities as well, we could always make a substitution for sine squared and call that 1 minus cosine squared and get a second formula. So not only does cosine of 2x have a formula of cosine squared minus sine squared, it also has another identity of 2 cosine squared minus 1 is equal to the cosine of 2x. Likewise, I could use the Pythagorean identity of cosine squared is equal to 1 minus sine squared and substitute that into the cosine squared minus sine squared identity. In doing so, I get 1 minus 2 sine squared. So there's a third identity for the cosine of 2x. Again, you can memorize these, or you can take and grind them out using the sum and difference identity. Finally, tangent. If I do the sum and difference for tangent of 2x, I have the tangent of x plus x, which is the tangent of the first plus the tangent of the second over 1 minus the tangent of the first times the tangent of the second. And since the first and the second are both x, I have 2 tan over 1 minus tan squared. And there's our third identity. So we're going to use these in order to do some identities and some solving type equations. So let's go through first. We're going to start with more, if you will, triangle type problems. We know the cosine of x is 3/4, which means I know automatically, since it's not a unit circle type problem, I just say, well, here's my x. I have a cosine, which is the adjacent in a hypotenuse. And so I'm probably going to need to find this vertical side in order to get my problem done. So I've got 16 minus 9 is equal to the y term squared. And we know that's 7. So the square root of 7 is equal to y. And there's my triangle. And I know I'm in the fourth quadrant, so this would be a negative value. Now we need to find the sine of 2x, and the sine of 2x, as we've already found, is equal to 2 times the sine of x times the cosine of x. And fortunately enough, I can find that from my triangle picture. So I have 2. The sine of x is negative root 7 over 4, and the cosine of x is 3/4. Multiply everything out. Notice I have 2 and the 4 reducing to 2. So I have negative 3 root 7 over 8, and that's equivalent to the sine of 2x. Another triangle problem, because I know that negative 3/7 is not, says this triangle is going to be in the fourth quadrant, once again. So let's go ahead and draw that fourth quadrant triangle. And I have the sine given to me of 3/7. That guy's going to be negative. So I have 49 minus 9 is equal to x squared. So I have 2 root 10 equaling x. From there I can get anything I need. I have a tangent formula that I have to deal with. So tangents equal to y over x, which in this case is negative 3 over 2 root 10, or negative 3 root 10 over 20 after I rationalize. And I have the tangent of 2x equals 2 tan x over 1 minus tan squared. So 2 tan x is equal to 2 times negative 3 root 10 over 20 over 1 minus negative 3 root 10 over 20, and that's quantity squared. This gives me negative 3 root 10 over 10 over 1 minus, that's 9 times 10 over 400. That's going to simplify a little bit. Negative 3 root 10 over 10 over 1 minus the 10 and the 400 go to a 1 and a 40, so that's 9/10. And we can simplify that a little bit more. Let's go ahead and do that. This is negative 3 root 10 over 10 times, this is 1 minus 9/40. Then we know that's going to be 31 over 40 multiplied by the reciprocal, so it's 40 over 31. And I end up with negative 12 root 10 over 31, and I'm done. So those are the easier type of problems where you know they're just triangle problems. Next, we're going to do a verification. So this is more of an identity, and I want to show that the sine of 2x over 1 minus the cosine of 2x is equal to the cotangent. So I'm basically looking for a cosine over a sine. I only have one identity I can use for the sine of 2x, which is 2 sine of x cosine of x. And what I want to have happen here, remember I said I want cosine over sine, is I want to get rid of this sine on top. So in order to do that, I'm going to try to get nothing but sines down on the bottom. So I'm going to use the identity that contains only sines in it for the cosine of 2x. Remember, I have 3 to choose from. This is 1 minus 2 sine squared of x. 2 sine cosine. Notice the 1's subtract off. I'm left with 2 sine squared of x. The sines reduce, the 2's reduce, leaves me with cosine over sine, which is the cotangent, which is what I wanted. Here's another identity. I'm looking for 2 times the cosine of 2x over the sine of 2x is equal to the cotangent minus the tangent. I'm tempted in this case to work with the right side instead of the left side because I think I can get cosine over sine minus sine over cosine. I think there's a lot more to the right side even though it looks simpler than the left side, so I'm going to go ahead and do that. And I'm going to need two terms and a difference. So I'm going to go ahead and go, this is 2 times the cosine squared of x minus the sine squared of x over 2 sine of x cosine of x. Now, like I said, I need a subtraction, so I'm going to split this into two different fractions. This is 2 cosine squared of x over 2 sine of x cosine of x minus 2 sine squared of x over 2 sine of x cosine of x. And you'll notice the reductions I get here. 2's reduce, the cosines reduce, so I'm left with cosine in the numerator, sine in the denominator, minus 2's reduce, one of the sines reduce, sine in the numerator, cosine in the denominator. And what do you know? There's cotangent of x minus tangent of x, which is what I was looking for. Okay, so now we're going to take and solve for x given values for x between 0 and 2 pi. I know I have a sign in my problem. I'm going to take and, as always, try to set aside equal to 0. And now, if I'm going to want to factor, I will probably need an identity for the cosine of 2x in terms of just sine. So that's 1 minus 2 sine squared of x minus sine of x equals 0. I'm never a fan of factoring anything with a negative squared term, so I'm going to multiply everything by a negative 1 and then put it in the proper order. So that's 2 sine squared of x plus sine of x minus 1 equals 0. Therefore, I have 2 sine of x sine of x, 1, 1, plus here, minus here. So 2 sine of x minus 1 equals 0. Sine of x plus 1 equals 0. Therefore, sine of x equals a half. And sine of x equals negative 1. Where do I have a y value of a half? That's at pi over 6. 5 pi over 6. Remember, I use both since I'm looking for values between 0 and 2 pi. And then I have a y value of negative 1 at 3 pi over 2. And that gets me done. Next example. So here we have a situation where we're trying to find values for theta between 0 and 2 pi again, but we have a sine of 2x identity, which I know is 2 sine cosine. I'm going to use x's instead of thetas because they're just a little easier to write. Now typically when I have 4 terms in my problem, I know I'm looking to factor by grouping. So I notice in the first set of terms I have a sign in common. So I'll pull out a sine of x, have 2 sine of x, oops, I lied, have sine of x times 2 cosine of x minus 1. And then I'm going to pull a negative 1 out of the next term, minus 2 cosine of x minus 1. And you'll notice I've grouped that nicely, such that I have another common factor of 2 cosine x minus 1 that I can factor out. And that leaves me with the sine of x minus 1. Set that equal to 0. Therefore, I know each of those could equal 0, so cosine of x will equal a half, and the sine of x will equal 1. Where does my x value equal a half? Well, that could be at pi over 3 and 5 pi over 3, because I'm between, once again, 0 and 2 pi. And sine will equal 1 at pi over 2, and those are my solutions. So the big thing about today is really, unless you have the cosine of 2 theta identity, you will have no other choice but to use the identity given. However, if you have the cosine of 2 theta identity, you're going to have to pick one of the three which is best to use. So a little bit of practice will get us a long way with that.